and all. Good morning. The subject name is compiler design. In this subject, previously we discussed about some of the concepts that is related to runtime environment and type checking process, which are involved the various problems in that. Now, in this lecture, we are going to discuss about some of the problems which are related to code optimization and generation process. That is the phase which is available in the last phase of the compilation, that is optimization and generation phase. Now, for example, in this example, we know that various blocks of information that is to be kept as a series of statements. So each block maintains some set of instructions or lines of code. Say here that is a B5. B5, that is block 5. So in this block 5, we are going to calculate 4 star I as an assignment statement, that is T6. Once again T7, T6 calculating 4 star I. So this is a step which is involved, the assignment statement, and this expression is evaluated several times. So this is comes under common subexpression elimination. Common subexpression elimination. This is called as common subexpression elimination. Even if we eliminate the common sub, means 4 star J, T8 and T10. These two are related to, this is T6, T7, this is T8 and T10. So these two expressions are relating the same. So instead of taking the two expression computations, we are performing T6. Instead of T8, we are going to take T8 computation. Why? Because in the next computation x equal to 8x, that is as it is, T9 is A of T8. So where the T7 appears, where we remove T7, but where it removes, we can also write a computation as T6, so that T6 computation makes the same result which gives the result computation for T7. So that's why here the 4 star I, the computation that is T6 instead of T6 has to be written instead of T7, and T8 is also be written instead of T10. So these computations are to be performed. So that is the elimination which is done in this case from B6, same block. So block of lines of code here, how many? 1, 2, 3, 4, 5, 6, 7, 8, 9 lines of code. But here in this case, 1, 2, 3, 4, 5, 6, 7. So 1 to 7 lines of code, 1 to 2 lines of code that is to be generated. This is the optimization of the code. Code optimization, we can use several principal sources of optimization where this expression of elimination can be taken place, so that we can get rid of the code with less amount of time, fast execution. So that instead of executing the repeated execution of the statement, say here 4 star I and 4 star J is to be repeatedly executing several times, the result is to be carried out with the same task. So that's why instead of that, so out of 1 to 9 lines, 10 lines, we reduce it into 7 lines. So reduced into 7 lines of code. We can reduce it into 7 lines of code, 1 to 7 lines of code. That is the called as this example mainly specifies the common subexpression elimination inside a block. Inside one block, inside block, common subexpression elimination. Common subexpression elimination. So even though if we eliminate the expression, the result of this block, what is to be executed, which is same as the result of the bag which is to be executed for this one also. So the result must be the same after elimination of expressions and this one. So in such a way that we can verify these lines of code. Another example is copy propagation. In the copy propagation, that means instead of writing the statement, the variable name that is here, we are going to copy a copy statement which is saying suppose f equal to g. So instead of one variable, we can write another variable. So this is instead of writing this one, we are going to eliminate so that one repetition of the cases. For example, the variable x, it is to be used, that is pi. So x equal to pi, a equal to x star r star r. Now in this, the x value is to be occurred as a copy statement. Why? Because x equal to pi. So now the pi is to be used, and then the r and r. So instead of writing this statement, copy statement, and these two lines, we can be able to write this a single line of statement, and that we can eliminate x. Here, instead of writing the two statements alone, instead of that, we can write a single statement alone, and then we can eliminate that variable x equal to pi. What is the meaning of x equal to pi? It is to be substituted with the same meaning previous to that computation. So that's why we are going to use this copy statement instead of one variable instead of another. But this is to be appearing twice. That means this x assignment and then substitution. So both are to be taken place. So instead of that, directly substitute this value as pi instead of x, so that we can get rid of this line of code into single line of code and the x variable. So we can get rid of some of the variables. So use this example mainly specifies the assignment statements are called as copy statements, and these copy statements are to be used whenever necessary, and then to improve the code performance also these techniques are to be applied. Another one is example which specifies the dead code elimination. So what is dead code elimination? So here in this case, whenever the part of the code that is to be executed several times, sometimes the code that is to be entered or not, we have to check out. So in this case, I equal to 0, that means this line of code is to be executed or not. Since I equal to 0, if you specify I equal to 0, then if condition may not get the result. So if statement, it is a dead code. If statement is a dead code in this example. So this condition never execute, but here the condition is true now. We are saying that the condition I equal to 0 indicates that I value is also already assigned, that is, it is a false. Then there is no chance of doing evaluation of this. It cannot come to this, and this part of the code can't be executed. So if these lines of code are available in the program, and also this code is not used for compilation or running compilation purpose or any other purpose, then our computation doesn't take place for the computations of this code. Computations of this code doesn't occur. That means there is no involvement in the beginning inside the environment is like this. So we are going to do this computation for several times, and this repetition of the code doesn't occur. So in this case, this code is to be executed several times, but even though the effect of this code presenting of this availability of this code may not involved in the remaining part of the program or anywhere else, then that type of code is to be identified. Then that code is said to be a dead code. That means dead code is a code where the line of statements are available in the program, but it may not take part during the execution of the program, or computation points, or it is a useless code or dead code, we can say that. So it is not at all used inside that any of the commands. So that code to be identified from that one, and the programmer is free from this type of code, so that results may not affect the or any other variables which are to be used in this one. So the results are to be sometimes transformations takes place. So that's why here this code is to be identified at the proper invent time. So that here in the example, if you take this statement is to be used. So that code is because this condition will never get satisfied. So this is the environment which is to be available. And where is the second? That is the next one is in this example. So here we are going to take the two examples. First example is where this the value that is to be division. So here division. This is a slash operation, division. So this operation is to be performed with some a equal to 3.14157 divided by 2. So instead of giving this division computation, so we can write directly the statement such as a equal to 1.57. A equal to 1.57 instead of writing. So that means the division operation is to be eliminated. So only the assignment. So any difficulty of the taking any difficulty of the expression evaluations are taking place, then that this leads to the compile time reduction. This is the reduction of compile time. Why? Because this operation I am not performing. Instead of this operation, this computation I am replacing with directly this one. So even the result is same. Even though if you perform division operation, if you are performing division operation, we are getting the result is what? 1.57 only. Instead of that performing that computation and wasting the time of compilation point and running time, directly we are going to assign this value and we are going to save. This is the one of the advantage of copy propagation. Turns the in order to make this expression a constant value. Instead of this is called as constant folding. This is called as constant. So instead of describing the expression and calculation, that means here only division. Any other plus minus also like that computation we are going to calculate that value of the expression. Instead of putting the operators plus minus diving, we are going to give the value of the expression. Value of the expression. Then this is a constant. This is called as constant folding. Say for example, so here copy propagation that how the dead code is eliminated in the second example. If you are going to observe, see here x equal to t3. X equal to t3. Now a of t2 equal to t5. Another a statement that is a of t4 equal to t3. Now what is t3 here? Go to equal to b2. Now here the statement a of t2 equal to t5, it is a of t4 equal to t3 and go to b2. But the x equal to t3 statement is not mentioned. Why? Because here if you assign the t3 value to the x, it doesn't affect the remaining statements of the lines of code. That means if we are assigned to the x or y or any other, but here t5 is assigned a of 2, t3 is assigned go to b2. So, but the presence of this line of code is a dead code. Instead of that, we can eliminate this code, and instead of assigning to x, and transformation takes place for this. So, these transformations is to be removes the assignment to x and transformed into a fellow notation. This is to be the exact code that is to be developed and used for the execution of the program. So that type of statements are also called as copy propagation. That means assignments, some of the assignments which are available in this one, and that is to be identified. That is to be identified. Another example, which one related to this code motion. So here code motion, we know that whenever the important code modified inside the loop, then several number of times the result is to be independent of that previous statements. That means while performing this code, when inside the statements are to be kept outside also sometimes, but whether it is affected or not, that is to be that is to be identified. So here in this case, the expression is to be calculated and the result verify whether it is independent of the, that means we are going to repeat the while loop several times. So this loop execution several times and placing of this code inside or outside may affect the remaining lines of code or not, that is to be verified. So before the loop, the existence of, that is called before the loop, some of the statements which are available, that is called as existence of entry for the loop. Now here we are going to see that in this example, while I less than or equal to limit minus 2. So this this condition is to be this computation does not change the limit, but code motion will result the equivalent of t. So that means here the limit minus 2, limit minus 2. So this is the computation which is performing every time for doing every time, that is every time for performing the execution of this while statement. So instead of recomputing several times, this limit value doesn't change. Instead of that, we can write that limit minus 2 and say some temporary variable that is declared as t, and the next statement while, that is to be kept inside while statement, and we are going to write this statement notation as I less than or equal to t. So in this example, we make the statement as a simplified statement so that it doesn't affect the remaining part of the results or previous ones also. So I less than or equal to t, simply what we are going to substitute this expression with this one. So now this one is to be computed before the while loop. Before the loop starts, this is computed. So our that means compilation point of view, this amount of time is reduced for calculation of this limit minus 2, and this does not change the limit value or any code motion. It is equivalent to, which is same as t. So that is to be kept outside of the loop instead of putting these lines of code as inside the statement. So this is the next, that is the actual statement which is to be written, that is I less than or equal to t. I less than equal. So now here I less than equal to t, which is equivalent to this previous, that is I less than equal to limit 2. So only the here the one is the part of this one can be assigned to some temporary variable, say t, and kept before this while. That means t equal to limit minus 2, and we are going to write this while as while I less than equal to t. So in this way, statement does not change with the limit or t. That means the computations of this limit minus 2 is a loop invariant. It is a loop invariant computation. That means doesn't affect that one, even though if you separate it. If any requirement with the loop, then we cannot make outside of this as loop statement inside. So that is why here this one we are going to limit. Now we'll come up with next problem solving technique. Thank you once again. We'll come up with one more solving technique next.
Like, share and subscribe. Hit the bell icon for more updates.